Complex numbers and imaginary numbers. Do you remember imaginary numbers? Imaginary numbers were the parts where we had to deal with negative square roots. If you recall, this does not exist in math. If you go ahead and ask Siri or ask your calculator to find the square root of negative 25, the answer is gonna simply be a math error. But there is a part of math that we start discussing and solving these. How? We're going to say that this equals to negative 1 times 25. And as you remember from radicals, we can separate them. So this is actually a 5 because this part is a 5 and we started calling this J, or sometimes in some books I. This is defined as the I or J. I call it J equals to square root negative 1. So that's going to be 5J. If I stands for imaginary, J stands for imaginary. So we have 5J there. Can you tell me what is the square root of negative 36? That is going to be 6J. So on and so forth. When we say we have a complex number, it means that it is composed of a real part and an imaginary part. For example, if I have 2 and then I want to add 3J to it, that is going to be a complex number. That is easily a, hopefully you see that, 2 plus the square root negative 3. This is one complex number. Can you make another one? How about negative 3 plus 2J this time? This part is the real part and that's the imaginary part. A complex number is composed of two parts, one real part and one imaginary part. We're going to learn today how to add them, subtract them. How do we add them? So if you have 3 plus 2J and you want to add to it a 5 plus 5J, you have two complex numbers. How do you add them? 3 and 5 could be added, and if you recall from algebra, 2J and 5J are like terms, so we just add them together, plus 7J. The same way you are able to subtract them. So for example, if we have 9 plus 3J, subtract from them a 2 and a 4J, it is going to be a 9 plus 3J. Expand the negative inside. And it's going to be 9 minus 2, a 7. 3J minus 4J minus J. This is how we subtract them. Now we want to practice their multiplications. I'm going to write down two complex numbers and I'll try to multiply them for you. So, what is J times J? J to the power of 2. If we have 3 plus 2J, we want to multiply to it 5, this time minus 4J. What's going to happen? From for method, we just multiply 4 multiplications. First, we multiply the real part of the first one to the second real one. What is 3 times 5? 15. What is 3 times negative 4J? Minus 12J. What is 2J times 5? And then what is 2J times negative 4J? 2J and 5 is a 10J. 2J and negative 4J is negative 8J to the power of 2. What are you going to do here? Do we have like terms? Do you see like terms? Yes and yes. So 15 minus 2J minus 8J squared. We realize that J is square root negative 1. What is J to the power of 2? j to the power of 2 is negative 1 to the power of 2. Anything to the power of 2, the 2 in the square root cancels, so j to the power of 2 is actually negative 1. So j is square root negative 1, and j2 is negative 1 itself. So let's take the negative 1 here and replace it there. So I'm going to have a 15 minus 2j minus 8 minus 1. And that is going to be 15 minus 2j plus 8. So 23 minus 2j. That was the first example of multiplying two complex numbers. Let's multiply another example. So I'm going to multiply 5 plus 3j, 5 minus 3j. By the way, these two are called the conjugates. Conjugates, when the sign in between changes. So for example, a plus b and a minus b are conjugates. So again, we have 4 multiplications to do. 5 by 5, 5 by negative 3j, plus 3j and 5, plus 3j and negative 3j. 5, 5, 25, minus 15j, plus 15j, minus 9j2. Plus 15j and minus 15j would cancel. I'm going to have 25 minus 9, and instead of j2, we have to put a negative 1. So that becomes 25 plus 9, and that becomes a 34. What did we learn? We learned that if we multiply two conjugates, we simply gonna get a whole number, a real number. That's how we get rid of complex numbers, or the imaginary part of a complex number.